Alright people, this is Algebra Section 7, Part 1, Factorising Quadratics. In this video, I'll give an overview of the topic, I'll then go through the worksheet, and finally I'll answer the questions that are on the worksheet. The description box below gives a link to any videos I reference within this video. It also gives you a link to my Instagram page where you can find images of the worksheet as well as the answers, so you can take a screenshot or copy from them, things like that. Right, factorising quadratics. I've already done a video on factorising. However, this video is specifically for learning how to factorise quadratics. Quadratics are equations that just crop up all over the blooming place. They are the equations that are of the form ax squared plus bx plus c, where the a, b and c are usually numbers. Now, a quadratic equation on a graph either looks like a smiley face or an upside down smiley face. And when someone tells you to solve a quadratic equation, what you're actually doing is you're finding out where that smiley face crosses the x-axis on a graph. And the way to solve a quadratic equation is to factorise. Factorising just makes solving them so much easier. So that's why we're learning this. We're learning to factorise quadratics so that we can eventually solve quadratics, so that we can eventually draw quadratics on graphs, yeah? Then once you can draw a quadratic on a graph, you've just nailed maths, basically. You've just done GCSE maths. I feel like when I was doing GCSE, that was like the pinnacle of learning. Got a quadratic equation, can draw this on a graph, watch me go. I'm so sad, honestly. Anyway, enough of that. Let's get on to factorising quadratics. In this video, we're going to factorise a certain quadratic. That's why I'm saying this video is part 1. Part 2 is also on factorising quadratics, but a slightly more complicated quadratic, so we'll come. Right, this is the worksheet for Algebra Section 7, Factorising Quadratics Part 1. So like I said in the introduction, quadratics look like this. Ax squared plus bx plus c, where a, b and c are usually numbers. When a quadratic is factorised, it will look like this, where d, e, f and g are again usually numbers. In this video, we're going to go over rules for factorising quadratics, where the a here is 1. In case you wanted to know, the actual name for this a is called a coefficient. It is the coefficient of the term x squared. The worksheet for Factorising Quadratics Part 2 will go over how to factorise quadratics when this a is not 1. But for now, we'll just go over examples where a is 1. Alright, rules for factorising. It's pretty simple really. If you have a quadratic that looks like this, x squared plus bx plus c, when it is factorised, it will look like this, bracketed x plus m times by bracketed x plus n. To find what m and n are, all you need to remember are these rules here, i.e. m times by n is equal to c, you see here, and m plus n is equal to b, this bit here. Let's look at some examples. Example 1, factorise x squared plus 5x plus 6. As you can see, this equation is a quadratic, and we know from the rules that we've just gone over that when factorised, it will look like the following. So we need to find what m and n are. To help us out with that, we also know from the factorising rules that m times by n is 6 and m plus n is 5. Let's go through some possible scenarios of what m and n could be. For this, I always like to draw out a table like this. Okay, if m times by n has to equal 6, then we could have this scenario. Here, m is 1 and n is 6. M times by n is 6. However, m plus n is 7. Now, we needed m plus n to equal 5, so this scenario doesn't work. We can also have this scenario. Here, m is 2 and n is 3. So m times by n is 6 and m plus n is 5. Well, that's perfect because this is exactly what we needed. We've found an m and an n that satisfy our factorising rules. Now let's just finish off. If m is 3 and n is 2, then our equation factorises to the following. Just to be sure, it's always good to check your answer. The way to do this is to expand your factorised expression and make sure you get back to your original quadratic. Here's me checking I haven't messed up because that totally happens sometimes. There we go. This was what we started with. We factorised it to this. We then took this, expanded the brackets, and got this, which is our quadratic from the beginning. Example 2. Factorise y squared minus 9y plus 14. Like we've gone over before, we know from our rules that when this is factorised, it looks like the following. Bracketed y plus m times by bracketed y plus n. We also know from our rules that m times by n must equal 14 and m plus n must equal minus 9. Again, I like to draw a table to find out what m and n are, and then I like to populate it with possible scenarios. So scenario 1, m is 1, n is 14, so m times by n is 14, but m plus n is 15. Therefore, this scenario doesn't work. Second scenario, m is 2, n is 7, so m times by n is 14, and m plus n is 9. Now we need m plus n to equal minus 9, so this scenario doesn't work either. Third scenario, m is minus 1, n is minus 14. Here, m times n is 14, because a minus times by a minus gives a positive, and m plus m is equal to minus 15. Still, this scenario doesn't work. What about this one? M is minus 2, n is minus 7, m times n is 14, and m plus n is minus 9. Therefore, we have the scenario we needed. If we take m as minus 2 and n as minus 7, then we get m times n as 14 and m plus n as minus 9. Thus, our quadratic can be factorised to the following. Bracketed y minus 2 times by bracketed y minus 7. Like I said before, it's always good to check your answer. So here we have it. I've expanded the brackets and I get this equation here, which is the same quadratic as I had at the start. Therefore, I know I've factorised correctly. Final example, factorise z squared minus 16. Again, we know that when this is factorised, it will look like the following. Bracketed z plus m times by bracketed z plus n. And we also know from our rules that m times by n must equal minus 16 and m plus n must equal 0. Because we didn't actually have a z term here. We only have a z squared term and a constant. So what are our scenarios? Scenario 1, we have minus 1 and 16. It satisfies the multiplication rule, but not the addition rule. Scenario 2, 1 and minus 16. Same again. This scenario doesn't work. Third scenario, minus 2 and 8. It satisfies our multiplication rule, but not our addition rule. Scenario 4, 2 and minus 8. Gives minus 16, but the addition rule isn't satisfied. Next scenario, minus 4 and 4. This satisfies our multiplication rule and our addition rule, so this scenario works. We could also have 4 and minus 4, which also satisfies both rules. You can choose which one you'd prefer. It doesn't matter. Therefore, m is minus 4 and n is 4, or you could have m as 4 and n is minus 4. So our quadratic becomes bracketed z plus 4 times by bracketed z minus 4. Once again, let's just check that. Expanding the brackets, we have z squared minus 16, which was our original quadratic. So we know we've factorised correctly. Right, this is a good stage to pause the video, try these questions yourself, then come back to the video and compare your answers and workings. Cheers!